So there is a relationship between the right and left limits and what we've been calling the limit, which is really more technically called the two-sided limit. So that when we first in section 2.2 introduced the notion of a limit, we're really talking about a two-sided limit. So this is what the relationship is. In other words, we say that the two-sided limit of f of x at at x equals c exists if the left and right hand limits are both equal to the same value, which I'm calling L. So if there's some limit L that both the left and right the hand limits are equal to, then we say that the two-sided limits, which we write as simply limit as x approaches c with no plus or minus on it, limit as x approaches c of f of x exists and is equal to L. So let's just see how that works in the context of an example. So here's a good example, just to use a familiar one. So does the limit as x approaches 0 of absolute x over x exist? Well, we saw earlier that the function y equals absolute x over x is simply, it looks like this. That's negative 1. That's positive 1. So what we can see easily is that what we saw rather we don't have to do it again. We can just write out what the left and right hand limits are. We know that the limit as x approaches 0 plus of absolute x over x is equal to 1. The limit as x approaches 0 minus of absolute x over x is equal to negative 1. And we can therefore say that these two are not equal to each other, and therefore, I think recall this from an earlier lecture in math, we write three dots in a triangle to mean therefore the limit as x approaches 0 of absolute x over x does not exist. And we've used this, we're going to encounter this even more in future sections, the notion of a limit that does not exist. We write DNE to mean that the limit does not exist. So this is the correct statement about that. We say that limit does not exist.